I'm going to just go through the lesson for 8.3 for Math 1 Honors. So it's about two-way frequency tables. All right, so part 1, Rashid is in charge of determining the upcoming after-school activity. So to determine the type of activity, Rashid asked several students whether they prefer to have a dance or play a game of football. So as Rashid collected preferences, he organized the data in a following two-way frequency table. So you can see why it's called a two-way frequency table. You have categories right here, like girls that he surveyed, boys he surveyed, the choices, football game or a dance. So you use the two-way frequency table for categorical data. So you have two categories, so you have categorical data. So Rashid is feeling unsure of the activity he should choose based on the data he has collected and is asking for help. So to better understand how the data is displayed, it's useful to know that the outer numbers located in the margins of the table represent total frequency for each row or column of corresponding values and are called marginal frequencies. So marginal frequencies are just like what they sound like. They're in the margins. So these numbers are marginal frequencies, and also these numbers, because they make up the total of the rows and the columns. Values that are part of the inner body of the table are created by the intersection of information from the column and the row, and they are called joint frequencies. So joint frequencies are basically what's in the middle. All of these pieces of data. So using the data in the table, construct a viable argument, like a reasonable argument, and explain to Rashid which after-school event he should choose. So when you look at the data, it looks like football, more people voted for football than dance, but very close, right? Just two more people. And then if you look at boys, definitely preferred football to the dance, and girls definitely preferred the dance to playing football. But notice that there were less boys surveyed than girls. I thought that was kind of interesting. So I think that either activity would be okay, but football had more votes. So if he was going strictly by votes, definitely 54 beats 52, right? Okay, so what we're going to do is we're going to practice making a two-way frequency table. So part 2, two-way frequency tables allow us to organize categorical data in order to draw conclusions. For each set of data below, create a frequency table, and when each frequency table is complete, write 3 sentences about observations of the data, including any trends or association in the data. So we're just going to organize this information. They're going to give us pieces of information that we know and then pieces that we have to deduce from that information. So it says there are 45 total students who like to read books. Well, if there's 45 total students, then that 45 is going to go right here, right? Because you're going to have the number of boys and the number of girls. So of those students, of those 45 students, 12 of them like nonfiction. Okay, well, of those students, we don't know boys or girls, but we know that 12 of them like nonfiction, and the rest like fiction. So if the rest like fiction, that's just going to have to be whatever 45 minus 12 is, right? Which is 33. Okay, so now we have some more information. We have 4 girls like nonfiction. So you would just go to where girls intersects with nonfiction. So you have 4 girls like nonfiction and 20 boys like fiction. So this is boys, fiction, you're going to put 20 here. Okay, so now even though they don't give you any more information, you can actually fill in the rest of the table because now you have enough numbers. So if the total of nonfiction is 12 and the girls make up 4, then obviously there's 8 boys that like nonfiction. How many boys were surveyed? 20 plus 8, 28. If there's 33 total that like fiction, and there's 20 boys that like fiction, then 13 girls make up the remaining part of that 33. And then 13 plus 4 is 17. So there were 17 girls surveyed. So this is just a frequency table where they're asking you to make some statements. There's lots of statements you could make. Like you could say more boys were surveyed than girls, right? Because 28 boys were surveyed, only 17 girls were surveyed. Another observation you can make, just a general observation, 13 girls like fiction or preferred fiction. You could make an observation like more surveyed students preferred fiction. So if you look at that, like here you have fiction, like just total students, and nonfiction. So more surveyed students, more of the students that they surveyed preferred fiction, right? 33 versus 12. All right, so those are just some general observations. All right, so what we're going to do is practice making another frequency table. So we have some information that we can fill in. Notice that here there's only one category, more than an hour, less than an hour. So we're going to have to fill in our other categories. So it says 35 7th graders and 41 8th graders completed a survey about the amount of time they spend on homework each night. So 50 students said they spend more than an hour. 12 8th graders said they spend less than an hour. All right. So we know that our 2 other categories are 7th graders and 8th graders. So we can put those here. 7th grade, 8th grade. Okay, and then we'll just fill in some information. It says 35 7th graders. All right, I know the total amount of 7th graders surveyed was 35. 41 8th graders. Total amount was 41. So I know that the total amount that was surveyed is just 76, right? Because 35 plus 41, 76. And then I know some other things. So 50 students said that they spent more than an hour. So more than an hour, I want to go to that category and go all the way over here. 50 students said that they spend more than 1 hour. 12 8th graders said they spend less than an hour each night. Now it says 12 8th graders. So I'm going to go to 8th grade and less than an hour and put 12 there. Okay, so now I can fill in the rest of the table just by subtraction, right? So 41 minus 12, 29. 8th graders spend more than an hour. Here I have 50 minus 29 for how many students spend more than an hour. So there's 21 students spend, 21 7th graders spend more than an hour. And then here I have 35 minus 21 is 14. And then how many surveyed spend less than an hour? It's just 14 plus 12, which is 26. And then you just want to make sure that your numbers add up here too. So see how They also add up to 76. And the observations you can make, you can just make various observations just like you did on the last table. Just make some various observations. But I want to spend more time of this lesson on specific observations by row or column. So I'm not going to write observations here. Okay. So now we're going to look a little bit about, talk about relative frequency tables. So we're going to go back to Rachel and her mom with this texting situation. So Rachel's thinking about the data that she and her mom collected for the average number of texts a person sends each day, and started thinking that perhaps a two-way table of the data they collected would help convince her mom that she does not send an excessive amount of text for a teenager. The table separates each data point by age, teenager and adult, and by the average number of texts sent, 150 or more per day, or less than 150 per day. So you see they filled in this two-way table. So just write two observation statements of this two-way table. These are just general observations. So you could say, oh, I noticed that an equal number of teens and adults were surveyed. So that's an observation. And another observation is, I noticed that significantly more people that were surveyed send less than 150 texts every day. So I could put an observation of that. So more people surveyed, at least this may not be true about all people, but just the people that were surveyed. More people surveyed send less than 150 texts daily, right? It's like 35 versus 13. That's this information here. So to further provide evidence, Rachel decided to do some online research. Makes sense? She found that only 43% of people with phones send 150 or more texts per day. She was disappointed that the data did not support her case, right? 43%. And was confused because it did not seem to match what she found in her survey, the data up here. So what questions arise from this information, and what data should Rachel look for to support her case? Well, what questions arise is, did she survey enough people? Like, what was her sample size? Did the online research showed that only 43% of people with phones send this information? Did the online research, how many people did they survey? Those are valid questions, like what's your sample size? And then what data should Rachel look for to support her case? So maybe if she wanted to support her case, maybe she should only use data from teens. I mean, that's a possibility, right? She could argue with her mom, like, well, not argue, but she could make her case. I'm a teen, so I'm going to interview teens and see if I'm, in the average range, if 150 is reasonable for my age group. So after looking more closely at the table, Rachel found other percentages within the same data that seemed more accurate with the data she collected from her teenage friends. How might Rachel use the data in the two-way table above to find percentages that would be useful for her case? So, I mean, there's lots of numbers in here. But I think that if she's trying to support her case that she sent 150 or more texts a day, then maybe she looks at, how many teens sent, because she's a teen, how many of those out of the total number of people, well, how many teens out of the total number of teens sent more than 150 texts a day? Okay, well, that's 11 out of 24, which is about 46%. So 46% of teens surveyed text more than or at 150 texts a day. So, she could argue maybe, well, 46% is almost 50%. So she could argue, make her case that like 50% send more, 50% send less, it's reasonable. So once Rachel realized that there are a lot of ways to look at a set of data in a two-way table, she was self-motivated to learn about relative frequency tables and conditional frequencies. When the data is written as a percent, this is called a relative frequency table. In this situation, the inner values represent a percent and are called conditional frequencies. Well, conditional frequencies are like what I introduced before, like joint frequencies. The data in the middle of the table. So the conditional values in a relative frequency table can be calculated as percentages of one of the following. So you can figure out these percents based on the whole table, like all of them out of this number, or you could figure them out by rows, those percentages, or by columns. So since Rachel wants to emphasize that a person's age makes a difference in the number of texts sent, the first thing she decides to do is focus on the row of values, of teenagers, so that she could write conditional statements about the number of texts a person is likely to send based on their age. This is called relative frequency of row table. Fill in the percentage of teenagers for each of the conditional frequencies in the highlighted row below. So this is the same data that she showed in the frequency table, but now we're going to fill it in as a relative frequency table. So we need percents. So if I'm just considering the row, then I'm looking at this as sort of the total in each row. So I want to know, what's 13 out of 24? Well, 13 out of 24 is about 54%. And 11 out of the total teens, 24, is about 46%. So see how 54% plus 46% is 100% of teens. Okay, then she can fill it in for adults. So 22 out of 24 adults is about 92%. And then 2 out of 24 adults is about 8%. So see, 92 plus 8, 100%. And then the totals. So 35 out of 48 total people surveyed is about 73%. So of the people surveyed, about 73% send less than 150 texts a day. And then 13 out of 48 is about 27%. So that adds up to 100%. Okay, so now, since the percentages created focus on row tables, all conditional observations are specific to the information in the row. Complete the following sentence for the relative frequency of row. Of all teenagers in the survey, so we're just looking at this row, right? Of all teenagers in the survey, blank percent average 150 or more texts a day, 46%. 46%. Now it says, write another statement based on row. So this is a really important point, that statements need to be made by information in the conditional frequencies or joint frequencies. So you don't want to make a statement by this row, because these are marginal frequencies, right? So you want to get information from the middle of the table to make your statement. So another statement that could be made is, and another way to make sure that you're making a statement by row is to start with of, and then whatever the title of the row is. And then ... So I'm going to look at these two rows. So I'm going to either say of the adults surveyed or of the teenagers surveyed, and then make a statement with these percentages inside. Okay, so I'm going to say of all adults surveyed. Okay, so that means that I'm focusing now on this row, right? Because I'm talking about of the adults surveyed. Of adults surveyed, 92% average less than 150 texts daily. That's a statement by row. Okay, so make sure that you are using the inside information. I would sort of highlight this information. Statements need to be made by information in the conditional frequencies, not marginal frequencies. Okay? All right. Let's try this again. Okay, same information with the text, but now we're going to look at it relative frequency of columns. So now we're going to not look at it as just teenagers or just adults. We're going to actually look at it in terms of columns. So I still have the same information. I'm just going to copy it from my last table, right? So I'm just going to put it over here. I have 13 here, 11 here, 24. I have 22 here, 2 here, 24. I have 35, 13, 48. Okay, I still have the same data, but now my percentages are going to look a little different because I'm looking at them as this is 100% of the column. This is 100% of the column. So now I just want to look at it like, oh, I don't want to do 13 out of 24. That would be by row. I want to do 13 out of 35, the total of the column. And that's about 37%. And 22 out of 35 is about 63%. So your percents, you're going to round them, but they should add up to 100%. And then here, I want 11 out of 13, because that's the total of my column. So 11 out of 13 is about 85%. 2 out of 13 is about 15%, right? So 85 plus 15 is 100%. And then I have 24 out of 48, because that's my column, which is 50%, and 24 out of 48, which is 50%. So now what I want to do is I want to write two conditional statements using the relative frequency of column. Now remember, I only want to use information from this area. So my statements should have something, one of those percentages in it. So for example, I could write, and remember, it's easier to start with the title of your column or the title of your row. So I'm going to start with of, and then the title of the column, because I'm writing a statement by column. So I'll say, of those who send, okay, I need to use one of these. Of those who send greater than or equal to 150 texts daily, 85% are teenagers. Okay, I can make another statement. I can say, of those who send less than 150 texts daily, you could say 37% are teenagers, 63% are adults. I'll say 63% are adults. Okay, so those are statements by column. I'm only looking at, I made the percentages based on column, and then I'm using some information here. I'm starting my sentence with one of these two titles. Now, another way that we can look at relative frequency is of whole table. So that is when we are comparing all of the numbers to this whole number and making percentages. So I know that up here I have 13, right, from my data, but it's going to be out of 48. And 22 is going to be out of 48. And 35 is going to be out of 48. And 11 is going to be out of 48. 2 out of 48. 13 out of 48. 24 out of 48. 24 out of 48. We're going to make our percentages that way. So the percentage that goes here, see, it's all by whole table, is about 27%. This is about 46%. This is about 73%. Okay, that adds up, right? 27 plus 46, 73. Okay. So 11 out of 48 is about 23%. 2 out of 48 is about 4%. 13 out of 48 is about 27%. And of course, these are 50%. Okay, so now I want to make some statements, some conditional distribution statements for the relative frequency of whole table. So now the beginning of my sentence wants to start with of all people surveyed. So of all people surveyed, you don't want to say of all people because that may not be true of everyone. It's just true of the people surveyed. Of all people surveyed, 46% were, okay, now here's the part that you got to pay attention to. You need to have two pieces of information in each sentence, in each statement, because now you didn't start with one of your categories, you started with of all people. So always make sure when you're writing a statement of whole table that you have two pieces of information in each statement. So of all people surveyed, here's my first piece of information. 46% were adults. Okay, so I have 46% were adults. Were adults who what? No, that's not, I can't leave it that way, right? Of all people surveyed, 46% were adults. That's not true. 50% were adults. That's why I need to add more information. Of all people surveyed, 46% were adults who send less than, just less than, right? Less than 150 texts daily. There's my second piece of information. My second sort of identifier. Less than, so I have two pieces of information. Here I have adults and I have less than 150 texts daily. So that's one statement. My next statement is also going to start with of all people surveyed. And then I just find another piece of information. Oh, 23% were teens, right? Were teens who what? Teens who average greater than or equal to 150 texts daily. Okay, so I have two pieces of information, teens and the number of texts. Okay, so how do relative frequency tables impact the way that you look at data in two-way tables? You can really see that based on what you want to emphasize, you can look at percentages in different ways, and it's going to sort of skew the information to what you're trying to convince someone of. So you could say something like percents can seem different or more influential. I hope I spelled that right. Depending on whether you figure by row, column, or whole. So depending on what you're trying to influence, you can look at them in different ways, right? Okay, so on the back we have some more information. We have student test percentages. He says, use the data below to create the following tables. Make an observation about each table. So you have student test percentages, boys, girls, okay? So here you have scored 70% or higher. Okay, now this table, let's say, is, has the information in it, but this table that we're about to make, it just says two-way frequency table, not a relative frequency table. So I want numbers only, no percentages. This is raw categorical data, no percentages, right? Because it's not relative. So I'm just going to fill it in. So when I looked at the boys, I found that 21% or 21 of them got 70% or higher. 19 girls did 70% or higher. So that was a total of 40 students that got 70% or higher. 3 boys had below 70. 5 girls had below 70. So that means 8 students got below 70. Total of boys, 24. Total of girls, 24. Total of students, 48. Okay, just a frequency table. Now I'm going to use this data to fill in these tables. Now this one is going to be by row. So we are always going to just be going in this direction, right? Row. Okay, it's a relative frequency table, so that means that we're going to put in percentages by row, row, row. Okay, so we know that 21 boys, 21 out of what? 21 out of 40, because remember 40 was over here. So 21 out of 40, about 53%. 19 out of 40, about 47%. Here I have below 70%. 3 out of 8, remember there was 8 here from our up here. And then So 3 out of 8, I need to plug in my computer so it doesn't die. Okay, 3 out of 8, about 38%. And then 5 out of 8, which is about 63%. You know, this is 37.5, this is 62.5. You could fudge on those a little bit. And then you have 24 out of 48, which is 50%. 24 out of 48, which is 50%. Okay, that's by row. And you can make a statement by row, like, of those who scored 70% or higher, 53% of them were boys. That would be an example of a statement by row. Okay, down here, we're going to do a relative frequency table. That means we need percents of column. So here's a column, right? Here's a column. Just like matrices, right? Row, column. Rows are horizontal, columns are vertical. So now I'm going to fill in these numbers down here because these are my totals that I'm going to do my fractions out of. So now I have 21 out of 24 by column, right? Because I'm going this direction, this direction, this direction. Okay, so I have 21 out of 24, which is about 88%. Look how different that is than this by row. 53%, 88%, depending on what you're trying to say from this data. Those are really different numbers. 3 out of 24 is about 12%. 19 out of 24 is about 79%. 5 out of 24 is about 21%. So here you have 40 out of 48, which is about 83%, and 8 out of 48, which is about 17%. So you can make statements by column. For example, a statement by column of this data would be, of the girls who took the test, 79% scored 70% or higher. So you would start with of the girls or of the boys. Up here for row, you would start with of those who scored 70% or higher, or of those who scored below 70%. So we're going to combine all the data for boys and girls and create a box and whisker plot for the data. And remember to find, this should actually say a modified. It should say modified because down here it says be sure to check for outliers. So if you're having to check for outliers, then that must mean that you have to modify your box and whisker plot if there are some outliers. So I went ahead and listed all of the data to find this information. So I listed them in order, like combined them, and it was 12, 35, 54, kind of mundane, 56, 58, 67, 67, 68, 72, 73, 74, 75, 76, 76, 76, 76, 77, 77, 79. Oh, so boring. 80, 81. Then I had to go again. 82, 82. I couldn't even fit them all in the same row. 85, 85, 86, 86, 86, 87, 88, 88, 89, 89, 90, 91, 92, 92, 95, 96, 96, 98, 98, 99, 99, 99, 100, 100. So even though that seems so tedious, I mean, I just don't think that there's any other way to do it because you have to combine their information. Okay, so since there's 48 pieces of data, then I know that the median must be between number 24 of data and the other 24. So actually, my median ends up falling right here between the first two 85s. There's 24 pieces before that, 24 pieces after that. So my median is 85. My Q sub 1, or my first quartile, if there's 24 pieces in the lower half, then my first quartile must fall between, like, it must be the number where there's 24 is divisible by 2, right? So you have 12 numbers below, 12 numbers above. So my here's where I have number 12 piece of data and number 13 piece of data. So my Q sub 1 must be in between those. So I just have to take the average, 75.5. My Q sub 3, my upper quartile, it has to be starting with the halfway through. It must be between my 12th and 13th piece of data, which is actually right here. So I have to take it in the middle, 91.5. And then my lower extreme, or my minimum, is easy, right? 12. My maximum, or my upper extreme, is 100. All right, so now I have to just test for outliers because it says be sure to check for outliers. All right, so I'm going to test for my test for low outlier. So when you test for the low outlier, you take Q sub outlier, you take Q sub 1, 75.5, minus 1.5 times the inner quartile range. The inner quartile range is when you subtract Q sub 3 minus Q sub 1. So 91.5 minus 75.5, and I end up with 51.5. So are there any test scores that I have that are below 51.5? Yeah. So I have some outliers, right? My outliers are 12 and 35. So what I'm going to have to do is I'm going to have to refigure my 5-number summary without 12 and 35. Those are my outliers. And I also need to mark them on my box plot. So 12 is about right here with a little X, and 35 is about right here. So I have to indicate that those are outliers. Okay, so now I have to test for higher outliers, right? So I take Q sub 3, 91.5, and I add 1.5 times the inner quartile range, and I get 115.5. So there's no scores above 115.5, so I don't have any high outliers. Okay, so now what I have to do is I have to refigure this information. So this is my new median. Well, my new median, now I don't have 48 pieces of information. Now I only have 46 pieces of information because I had to throw out my 12 and my 35. So let's see if I can move this down a little bit. All right, so my new median is actually between bottom 23 pieces of information and the top 23. So it actually ends up being, oh, maybe I missed an 85 in here. So my first one was here, but my second one is actually here. Okay, so it's still 85. And then my new Q sub 1, well, if I have 46 pieces of information, then I have 23 on the bottom and 23 above the median. So that means that my new Q sub 1 has to be 76, like it's my first 76. So Q sub 1 is 76. Q sub 3 is actually, if I count halfway, my upper half is 92. It's this 92. Oops, why did I write that again? I meant 76. Okay, and then my lower extreme, or my minimum, my new minimum is 54. and my upper extreme stays the same. My upper maximum stays the same, 100. So I'm going to go ahead and make my modified box and whisker plot. My lower extreme, 54, about right here. My Q sub 1, 76, about right here. Q sub 1, lower extreme. My median is about right here, 85, median. My Q sub 3 is 92, so right about here. And my upper extreme is 100. So it's Q sub 3, this is my upper extreme. Okay, so I'm going to go ahead and connect my whiskers and then draw in my box. So middle 50% of information. Okay, so I know that this part down here was a review of 8.1, but it's good to practice, and especially for a modified box and whisker plot. A lot of students forget that when you find the outliers, you have to refigure your information. Okay, so I hope that was helpful, and I will go ahead and post this video on Google Classroom so that you can stop and go as you please. All right, have a great day, guys. Bye.